Good morning, everybody. This is another video of our AIOps Explained video series. Today, we're going to talk about match tokens. So this is around event data, which is then mapped to topology data to make, for example, topology correlations. And we're going to show you this in the IBM Cloud Pak for AIOps version 4. Today, I have my colleague Zane with me, and please say hello.
Hi, everyone. Hi, Fred.
That was very short. Well, today spring has started, at least in Frankfurt. So we have a proposed 20 degrees Celsius and the sun is shining for a proposed 9 hours. So that's really what I call spring. Looking forward to this evening. But back to the video, we have prepared a number of things. So this is the agenda we're going to talk through. So we're briefly introducing the Cloud Pak for AIOps, what it's positioned for in the automation portfolio. And then we are going into the topic of today, match tokens, why we have them and what they are doing. We are going to have a demo, which will be featured by Zane, and we're going also to give you vectors into the documentation, as well as Zane has already published a blog entry on the community. So that will be all parts of today's video. So this is the IBM IT automation portfolio. This slide is to be read from the left to the right side. We usually start talking our portfolio on the application performance layer. There we do have a strategic offering, which is Instana, one of our recent acquisitions. It's way more than just monitoring. It's what we call enterprise observability, because it's not just talking to the infrastructure, getting some metric, but it's also about tracing the infrastructure, discovering the infrastructure, finding about who's talking to who, and all these kind of things. So quite a nice product, and also quite easy to install and easy to use, and therefore it's a really good starting point into the IBM IT automation portfolio. But we also have on the lower layers network management tools in the pocket. So we could do network discovery, network monitoring, we could do change management, and last but not least, also network performance management, which is covered by our acquisition Ceph1. Once you have mastered that or using something else, you may want to optimize your resource management. In cost-effective resource management, we do have now two offerings which are quite nicely playing together. One is the Tokenomic Application Resource Manager, which has capabilities to take load data from your infrastructure, map it to applications, and see and observe how these applications behave, and in the background try to find optimization points which help you to save on money and make at least the same performance with less footprint and at the end less cost. And if you want to expand that kind of story more into the FinOps direction in making more visibilities into procedures, map that to cost structures, then we have the Aptio portfolio, one of our most recent acquisitions. So all these two things make a very nice and round FinOps story. And that also provides quite an interesting part of the story, because out of the resource management part, we do get a really good insight into change management. We already have events, performance data, time series data, all that comes into then the most right picture, which is our Cloud Pak, the IBM AIOps portfolio. In there, we consolidate all that. So this is the IBM AIOps portfolio itself. So we do have a number of entry points, data ingestion points. So we collect events directly from the infrastructure or via element management systems or systems which do have already a good insight into what is happening in that environment from a time series, from a connectivity, and from many other perspectives. And so this is directly pouring data into the AIOps portfolio or via element management systems. And we do that from many standpoints. We have events, metrics, we do have connectivity data, which we call topology. We do have log information, ticketing data. All that is received and then merged and set into context via applications. So applications is what we want to globally picture together. And then we want to find out, do we have a problem? Then we want to make everything possible to give you the means of where is the problem, what to do about the problem, and then rectify the problem as fast as possible. That is what we do within the Cloud Pak for AIOps. And today we're concentrating on just events and connectivity data named topology. And we want to show you how those two things go together and how the magic is done in that area. So that's the topic of today. Of course, we do have documentation, and one of the best starting points for this kind of correlation is match tokens. So when you go into our documentation, the most recent version today is version 4.4.1, and you look for match tokens, then you start with defining match token rules, and this is going to be a good starting point for reading around what's all that. Then, of course, we have the community. Zane has already published a blog around this topic of today. Here's the link to it and a picture of the top section of that community post. And with that, I'd like to hand over to Zane to take you away with this topic and show you the demo. Zane, over to you.
Thanks, Fred. Okay, thanks, Fred. So today we're going to take a look at how events are mapped to topology resources. What you can see here at the moment is an event list. We receive events from all different sources, and we also have topology observer jobs, which acquire topology data from lots of different sources. All of this data flows into AIOps, as Fred was showing on the previous slide, and some of those events are mapped to the topology. So you can see on my screen here, I have a group of 8 events here, and those 8 events are all found in the topology. When I double click on one of these guys, it gives me a little preview of the topology with that particular resource centered in the middle. What we're looking at today is how this is happening. How are these events mapped to the topology? What we're going to take a look at now, we'll jump to the topology itself and we'll start to look at what topology data looks like. So we've got a collection of topology resources on the screen, and each one of these resources has some details associated with it. If I click on resource details, I can see all of the attributes that relate to this particular resource. So you can see here the name, entity types, create time, and a bunch of other things. If I switch on the show JSON, it actually shows me all of this stuff, but also a couple of hidden fields as well. One of those is called match tokens. In this case, my match tokens for this particular resource include this string here and this string here, which is basically corresponds to the name of the resource as well. So what are match tokens for? Well, what they're for is the system uses the match token values to try and map those to the events that are coming in. And if it does find a match, then it maps those events to those resources. If I click on the alerts tab here, you can see I have an alarm or an alert associated with this resource. So what we're looking at today is how these actually get mapped. So I know that the match tokens are, in this particular case, are these 2 values. If an alert comes in and the alert has come from a resource that is equal to either this value, entity ID .111108, or this host name here, then the event will get matched to this resource. So how are match tokens defined? Well, many of the off-the-shelf observers actually set the match tokens for you. A lot of these off-the-shelf observers, they understand the nature of the source of the data, and they know which of the attributes make appropriate name, for example, for the resource. But also, it has an understanding of the event coming from that source, and therefore which attributes in the event should map to the attributes in the resource, and therefore which of those attributes I should add to the match tokens list, if that makes sense. So the question is, how do we define match tokens if the match tokens don't exist? If we're not using an off-the-shelf observer, then we need to actually go and set up some match token rules. So let's say I'm loading in topology using the file observer or maybe the REST observer, and I'm getting some generic topology from a generic source, and I want to actually tell the system which of the attributes I'm going to use for the match tokens. So for this, I'll go into my topology configuration under rules, and I'll click on match token rules. In here, there's a bunch of out-of-the-box ones for different kinds of things. You'll get a bunch of these created for you when you install certain kinds of observers, but you can also create your own. So if I click on new, I give the rule a name, and then what I'm going to do first of all is to add a list of the token names, test rule, that actually I want to add to the list of match tokens. So let's say I had a attribute coming in through my file observer called sysname, and I wanted to add that to my match tokens list. Maybe I had another attribute called hostname. I want to add that to my match tokens list, right? I'd basically add those attributes there, and then I would specify some conditions. So I might say, well, I only want this one to apply for topology coming through the file observer, and maybe I want to even be more specific and say, well, I actually want it to only come through this particular observer job, right? In my demo scenario. I can even go down to the resources. I can even specify only apply this match token rule to resources of this particular type. Maybe I'm, for example, setting it only for servers, for example, so add that to the list. Once I save this, this rule will take effect, and any observer jobs that will match this particular rule based on the conditions I've set out, I would need to rerun those observer jobs, and then those match tokens will appear in the topology. I'm not going to save that just now. That was just for an example, but you can see here those rules will be added, applied, and those match tokens will exist in my resources. So once I've done that, I should start to see events mapping to resources, as I can see in this case here. Now, the question is, from the events side of things, which attributes in the events are being mapped to the match tokens, right? So if I double-click an event and I click on the raw tab, I can see all the various attributes that make up this event that I'm looking at right here. So severity, the summary field, the sender.name, which is the node name, the resource.name, and various other attributes to do with the event. So which ones of these is AIOps actually trying to map to my match token? Well, that's a great question. So that's the other half of what we're looking at today. So the answer is there's a couple of attributes that come out of the box with AIOps. To take a look at which of the event attributes map to the match tokens, I need to jump into my deployment. What we're looking at now is the OpenShift console, and I can see I've got a bunch of operators installed as part of my AIOps deployment. The one I want to take a look at is the IBM Netcore Agile Service Manager. This is the topology component that the Cloud Pak uses to display all the topology data. And it's actually contained within this particular file is where we configure the elements that match to the match tokens. Under the Netcore Agile Service Manager operator, I can see a bunch of tabs here. The one of interest that I want to look at is the actual deployment instance of Agile Service Manager. So if I jump into the AIOps topology instance and click on the YAML, I'll be able to see all of the various default configuration for this particular deployment of the topology component. If I scroll down a bit, I should be able to see a sub-attribute under spec called Helm Values ASM. So these are some particular little configuration options that are set out of the box for various things. The one that is of interest here is the one called AIOps alert.entryPoint fields. They're the one that I've highlighted on the screen. And as you can see, out of the box, the topology is trying to map the attributes source ID and name to the match tokens, right? So source ID and name. So if I jump back to the events and I look at this event example, I look down the list, I'll find source ID and name. So what isn't immediately obvious is that source ID and name are actually sub-attributes of the resource attribute. So where it says here source ID and name, it's implied that they're actually resource.name and resource.sourceID. So as we can see here, this particular alert contains source ID of that and the name of that. Now, the order of these two elements is important. It's going to try to match source ID first. If it fails to find anything in the match tokens with that value, it will then look to the name and try and match that next. But that is how AIOps tries to map events to topology. It uses these values here. Let's say I have mapped some custom fields or any other fields into the event data, and I want to change this. I want to tell across the board, hey AIOps, I've got my own field here called resource.entity name, right? For example. Well, what I would do is I would simply add that value here. So I might add it even to the front. Entity name or host name or any other field name. As long as it's a sub-resource of the resource attribute, i.e. in this list, then I can refer to it here, as you can see here. Then all I do is I would save that, and the various pods would restart, and it would take effect. So a couple of things to note. It will only take effect for new events that enter the system, not existing events. So any change that I would make to the system here would only be applied to new events that arrive. Assuming that I made that change and the values coming through in the event stream actually map to match token values, then I would start to see the matching of events to topology resources happening based on my new values specified. So Fred, does that all make sense?
Cool. That was short and crisp. I love it. And I hope our audience as well, because this is something that is not really documented into that depth. So therefore, we're going to extend the documentation. Is that right?
Yeah, so in the meantime, this blog here actually walks you through much more concisely what I've just explained. So as you can see here, it shows you the match tokens screen and how that looks. Then it talks about going into the Agile Service Manager topology YAML file and tweaking the Helm values ASM value, and then saving that, and then how that will actually then start to take effect from that point on.
Yeah, thank you, Zane. That was really cool, as always, and I love it, as usual. I'm a fan of you. So that was the demo, and here is the link to our videos. So we do have on YouTube our repository of videos. It was in the IBM Support TV channel, and we do have at the moment something like 44 of those videos existing. Here are a few of those most recent. So how to install a demo environment using our GitHub scripts. So with just more or less 5 things, you can quite easily install a complete demo environment with demo data, pre-trained models and all those kind of things. It's in here in this asset. Have a look. Here's another video of how to combine an existing Netcool installation with, let's say, the new stuff, the Cloud Pak, because most of our existing customers do come from an existing Netcool environment and they want to expand that installation by reusing it for one, and then having all the new and cool stuff of AIOps beneficially merged into the existing Netcool environment. That's what this video is around. And then we do have a new video around custom fields, how to expand the default event schemas in the Cloud Pak. We do make a comparison between how it was in the Netcool environment and how it is now in the Cloud Pak. And with that, I'd like to thank you for your attention. Go out, don't stay too long in front of your screens. It's springtime, sun is shining. See you in another instance of AIOps Explained. And for that, bye.